In this video, we're going to take a look at the sine rule. You are actually given the sine rule under section 3.2 in your formula booklet. You are given that the sine rule is little a over sine capital A equals little b over sine capital B, which equals little c over capital sine C. Or it can be written as sine A over A is equal to sine B over B, which is equal to sine C over C. If you notice, there are capital A's and lowercase a's in the formula. This is to do with the way a triangle is named when you draw one. If you draw a triangle, you will name the corners capital A, capital B, capital C. And then the sides are the opposite. So opposite corner A is side A, which is named lowercase. Opposite corner B is side little b. And then opposite corner C is side little c. Right, to use the sine rule, you need two of the one or other of these scenarios. You need two sides plus one angle, or two angles plus one side. If you have either of these scenarios, you can use the sine rule to find missing side or missing angle. Let's go through some examples. Number one, use the sine rule to find the side length marked x to three significant figures. So we've got x and an angle of 21, and we've got 23 and an angle of 35. So we want to find the side, so it's x over sine 21 is equal to 23 over sine 35. Rearrange that, therefore we get x is equal to 23 times sine 21 all over sine 35. Therefore x is equal to 14.4 to three significant figures. Question 2. Use the sine rule to find the obtuse angle marked x to three significant figures. So we've got 33 is opposite a side 25, and angle x is opposite side 43. So because we want to find an angle, we put the sine on the top, so we want sine x over 43 is equal to sine 33 over 25. So if we rearrange that, we get sine x equals 43 times sine 33 over 25. So sine x is equal to 0.93677. So we now have to find the angle. So we want sine to the minus 1 0.93677, which is equal to 70 degrees. But it asks us for the obtuse angle. Right, in sine, we know, or you will know later on, that sine theta is equal to sine 180 minus theta. So therefore, we've got 180 minus 70, which is 110 degrees. So our angle is 110 degrees, and that will fit because 110 plus 33 is equal to 143, so it doesn't go over 180, so it will fit. So the obtuse angle that we want is 110 degrees. That is called the ambiguous case. In some instances, when you are using the sine rule, it is possible to get two different angles, one acute and one obtuse. Let's go through another example of the ambiguous case. Use the sine rule to find the obtuse angle x on the diagram below to three significant figures. So we've got angle x is opposite 12, and we've got angle 15 is opposite 7. So because we're finding an angle, we want sine x over 12 is equal to sine 15 over 7. So let's rearrange that. So we get sine x is equal to 12 times sine 15 divided by 7. So we get sine x is equal to 0.4437. So we want an angle, so x is equal to sine to the minus 1, 0.4437. So x is equal to 26.3 degrees. Therefore, we know that sine theta is equal to sine 180 minus theta. Therefore, we've got 180 minus 26.3, so x is equal to 153.7 degrees. 153.7 degrees. Will that fit in? So we've got 153 plus 15 gives us 168. So yes, that angle is possible. So our angle x is equal to 153.7 degrees.